Hi, I'm Arnie Gundersen from Fairewinds, and today I'm at the San Onofre nuclear plant that's in the background. San Onofre is presently shut down. It has steam generator leaks, and I wanted to give this demonstration today to talk about what it is exactly that a steam generator does and how they can leak. Well, this blue thing around me represents the key component in the side the steam generator, and it's called the tube sheet. It's 2 feet thick, solid steel, and 13 feet wide. So that's just about the shape and size of what I'm standing inside of. Now this would be a solid piece of steel before it's fabricated. Weighs about 100 tons, it's enormous. Now, first thing they do is they drill holes into this tube sheet. They drilled 9,700 holes on this side and 9,700 holes on this side. What happens then is when they put the steam generator together, hot water comes from the nuclear reactor, and that's symbolized by this orange pipe. So hot water would go through that. It's actually 32 inches in diameter, and 250,000 gallons every minute comes in. It comes in the bottom and goes up through these tubes, crosses over, and comes down on this side. Now where I'm standing is not the radioactive side. I'm standing on the non-radioactive side. Radioactive water is inside these, and hot steam and hot water is where I'm standing. Now, if you notice, these things are shaped like U's. That's why it's called a U-tube steam generator. The pipes come in, cross over, and come back in the shape of a U. Now, we've modeled up 3 tubes here. In fact, there would be 9,700 tubes on this side, and each one would cross over into 9,700 tubes on this side. When San Onofre decided to rebuild their steam generators, they made a design change, and I believe that it's that design change that's causing the tubes to fail inside. Right where I'm standing, right in the middle of this tube sheet, down below was a massive pillar. It was called a stay cylinder. San Onofre decided to get rid of that massive pillar down below to cram more tubes into the steam generator. Instead of 9,300, they got 9,700 tubes. By removing the place right below me, more tubes meant they could get more heat out and more electricity out. But it also changed the flow inside the nuclear steam generator. What's happening in San Onofre now is that these tubes are vibrating, and they're colliding with the pipes, with the pieces of metal that are designed to keep them separated. The vibrating tubes are hitting each other and hitting the support plates, and in the process it's denting the tubes. Some of the dents have gotten so bad that the pipe wall is completely worn away and the tube has to be plugged. We put these this far apart so we could show the U-tube shape of the tubes. In fact, they're incredibly close together. And there's 250,000 gallons of water squirting between these tubes every minute. 9,700 tubes on this side, 9,700 tubes on the other side, and all of them have about 1/4 inch of gap of water between them. What's happened is that the tubes are vibrating and hitting each other. And where they're hitting each other, they're wearing thin. At San Onofre, the one that broke was because it was hitting another tube, or it was hitting one of these tube support sheets. When that happens, not just one tube is damaged, but all the surrounding tubes are damaged as well. Now, the solution to this problem, as far as San Onofre is concerned, is to plug these tubes. They would send people down below and put plugs in the bottom of these tubes. That would keep the radioactive water out of these tubes. But it doesn't stop the vibration, because on the side I'm on, you've got non-radioactive water turning to non-radioactive steam up above. So this U-tube is actually much taller than I am. It would be up 20 feet, and above me would be high pressure steam, but it would be non-radioactive. As long as these tubes don't leak, no radiation gets out. So the new steam generators with their crammed tubes are banging into each other and banging into the supports. Again, there's all sorts of space in my design, but remember there's 9,700 tubes inside those domes behind me in each of the steam generators. They're colliding with these plates and denting the tubes. The dented tubes are then leaking, and the space that I'm in, which would be non-radioactive, is becoming radioactive. That's what caused the unit to shut down in January. Radioactive steam from inside this pipe broke through and entered the non-radioactive side of the piping. Now, the problem at San Onofre was stopped because they shut down quickly. They were releasing a half a gallon a minute of radioactive steam, but inside this pipe, it's 2,200 pounds per square inch. Where I'm standing, it's 1,000 pounds per square inch. So there's a lot of pressure difference causing that steam to shoot out. And in a very short time, if they don't shut down, that steam actually cuts these tubes and can cause a cascading problem, where one tube crashes into the next tube, crashes into the next tube. That's the most serious accident that could happen in the event of a tube failure at San Onofre, and it would require an evacuation of the people nearby. It would also challenge the emergency core cooling system, because the emergency core cooling system has to make up for the water that's leaving the nuclear reactor and entering the non-radioactive areas. So the solution at San Onofre is not to plug the tubes. Plugging the tubes stops the leaks, but it doesn't stop the vibration. The solution at San Onofre is to go back to the old design, to put that stay cylinder back in place so the vibration goes away, and at that point they'll have steam generators that last and are safe for the people that live near this plant. Thank you. The original steam generators at San Onofre were built by a company called Combustion Engineering, and they lasted 28 years before they were replaced. The new steam generators at San Onofre were built by Mitsubishi, and they lasted 10 months. The good question to ask is why? Fairewinds has been able to determine that the Mitsubishi design is entirely different than what the original design should have been in the combustion concept. Specifically, the tubes that go up and down are separated in the combustion design by something called egg crates. On the Mitsubishi design, they're separated by something called broached tube support plates. We have a report on the website today that explains this in detail, but basically what the Mitsubishi design has done is prevent the water from reaching the top of the steam generator. It's sort of like being strangled at the top, and only steam is getting up there. Well, in this environment, it causes the tubes to rattle. Not just a little bit, but so much so that they collide with each other. All of this could have been avoided if Southern California Edison had made the decision to license these steam generators with the Nuclear Regulatory Commission. If they had done that, the analysis would clearly have shown that the Mitsubishi computer codes weren't designed for the kind of steam generator that was built at San Onofre. So the lesson here is that Southern California Edison attempted to do what they called a like-for-like replacement of the steam generators. But the new generators were nothing like the original steam generators. Thank you for listening, and we'll keep you informed.